Find the exact value of the missing sides using special right triangles. So as you can see, we have tick marks here indicating that we have an isosceles right triangle, and we know the length of one side is 4, so that means the other side is 4, and then we have 4 radical 2 as the length of the hypotenuse. Okay, here we have the hypotenuse given in a 30, 60, 90 using special right triangle values. We know that the hypotenuse is double the length of the side that's opposite the 30. So if we take 1/2 of 10, this is 5, and the side across from 60 is 5 radical 3. We have the length of the hypotenuse of a 45, 45, 90. And the length of the hypotenuse is whatever the length of the missing side is, times the radical 2. I'm just going to set that equal to 7 and go ahead and solve. So I'm going to divide out the radical 2, rationalize the denominator. So get 17 radical 2 all over the square root of 4 is 2. So that's the length of the missing sides here. And they're both the same. I see you have a side opposite the 60-degree measure. So in order to get the value of that side, you take whatever is across from the 30-degree measure, and right now it's x, and you multiply a radical 3 to it. So that is equal to 5. So we're going to solve for x by dividing out the radical 3, and then we have to rationalize the denominator. So times a radical 3 times a radical 3, and we get 5 radical 3 all over 3. So that's the side opposite the 30-degree, and we're just going to multiply that by 2 and get the hypotenuse. So 10 radical 3 over 3. Given an equilateral triangle, so just this term equilateral means a whole lot of things. First, we have 3 equal sides, and we know that they're all 9. We're looking for the length of the altitude. So all sides are equal in an equilateral triangle, and all angles are equal. And if they're all equal, we take 180 and divide by 3, and we get 60-degree angle measures. Now here's my altitude. And when you draw an altitude in an equilateral triangle, that divides the opposite segment into 2 congruent parts. So we have 4.5 segments. And we want to find the length of the altitude. And it also divides the angle, it bisects the angle of the vertex here. So these are 30-degree measures. So altitude of an equilateral triangle divides angle into 2 congruent parts and 1 segments into 2 congruent parts. So I have the side that's opposite the 30-degree, which is 4.5. So that means the length of the altitude, which is opposite the 60-degree measure, is 4.5 times a radical 3. Okay, and that's just using special right triangle values. Now the second part is to confirm your answer with Pythagorean theorem. So the length of one leg is 4.5. And the length of the other leg is 4.5 radical 3. The question is that equal to 9 square? Okay, so 4.5 square is 20.25, and 4.5 radical 3 square is equal to 60.75, and 9 square is equal to 81. The sum of 20.25 and 60.75 is in fact equal to 81, so it proves to be true in the Pythagorean theorem.